industry workshop, industry research workshop today. So we are very pleased to have Compass IoT and UGL representatives talking to us about their industry challenges, their data dashboard, what they're actually doing, and essentially what they're looking for the next generation of engineers, transport engineers, and also civil engineers. So the first seminar is more about transport data analytics, but what we are actually looking for is what insights can we get from such a rich, intensive, expensive actually data dashboard that Compass IoT is providing on connected vehicle data, and how we can use it. So what are the use cases in terms of safety, transport safety, in terms of origin destination analysis, in terms of path analysis, and local governments, state governments, they're using this data for a variety of projects and their everyday, basically, tasks. But also, we are more interested to know that, the innovative mind of our students, what actually you suggest that we should move forward, and what can be done further than what the government or industries are currently doing. So I believe that David and Saloni will expand on it. But just letting you know the motivation behind this workshop, particularly the first one, is calling for an expression of interest from students. So David and Saloni, they're going to present about their data dashboard, the insights that they're using from this data, and then what actually they're providing to the government. But also, we asked for EOIs, just one-page EOI, research EOI, that you tell us that what you think you can do with this data if you get access temporarily, but like for instance, 1 month access to the data dashboard, so you can download freely, and then you can investigate the research questions that you have in one. And we're going to actually shortlist some of these interesting EOIs, if they're innovative or the ideas actually are new and interesting. And you will be eligible for Taste of Research Scholarship. So the Taste of Research Scholarship, I will I tell you that this is a scholarship scheme for undergraduate students in civil engineering and also in other disciplines as well, that you can get about $5,000, $6,000. I'm not sure this year is it 6,000 or not, for 60 days working with industry and also with researchers, to get to know about what actually researchers are doing, or some applied research for industry. So it could be combined industry research collaboration that will be engaged, but also be supervised by one of the researchers in rCITI. So we have Niad on the back, the founder of Footpath AI, and also I will ask Niad later on to talk about what he does in his courses, transport courses, that I believe the Compass IoT actually is a very good match. And yeah, so that's about the first seminar. The second seminar, we have Luke and Mason from UGL, that will Mason and Luke will talk about what do they do in their, again, everyday job, and also what are the research challenges that they face. And it's not only limited to transport, it's more basically broad. So it involves infrastructure, health monitoring, innovative construction materials, because the majority of their structures are like wooden, or they're kind of old, so they're approaching their end of life, and we want to see that what other new materials could be used. So very, again, innovative ideas, and we'll see that how we can actually progress with that. So without further ado, I leave it to you, David. I believe that you are marked up, so you don't need this.
No.
So please also start introducing a bit about yourself, your background, your bio. I think it's interesting for students to know, what career pathway they actually have. Okay. And over to you. Thanks.
Thank you. Hi, everyone. Good to meet you all. I'm Dave. My colleague Saloni is here as well. She's one of our data scientists at Compass. Can I just ask, who here is a student, either undergrad, postgrad? So like probably most of you. Who is a researcher? So, yep. Great. So a few researchers. Good to know. Awesome. Lovely. All right. I'll talk to you a bit about Compass. But I guess we'll put Saloni and I on the spot now and talk about ourselves a little bit. I am a proud graduate of UCS. I came out okay. And I found my way into the business world where I worked with startups and kind of tech companies for a long time. Does anyone here work in a startup at all or have founded a startup? Yeah, wonderful. Yeah, it's tough stuff, but it's worth it. And so I found my way into this company, Compass IoT, through the co-founders who are friends of mine. Compass started about 4 or 5 years ago. The whole idea came from a conversation with some local government transport planners in the ACT. And the problem was, how can we understand what vehicles are doing on the network? How can we understand how people drive, what their behavior is, what their speeds are, what they're doing and how they're making decisions? And that is what kind of spun out this whole company on the back of a growing data set, which is connected vehicles. So I guess point one is we're solving a business problem, which means that there's a demand on the business and government side, both here in Australia and overseas, which is that we really need to solve these problems, which means, firstly, there's money in solving problems. There's runway, there's growth, there's opportunity. We didn't come up with the problem ourselves. We essentially heard that problem from stakeholders and went out to solve it, if that makes sense. Cool. At any point, ask questions, by the way, because an hour is a lot of time for us, isn't it? Although I am ethnic and can talk for a long time. Anyway, point is, Compass, we collect data from connected vehicles. Does anyone know what that means? It's kind of, there's a clue on the screen. There's a specific part of this that's super important. Does anyone, what is it about the vehicle? Sensors? Yes, good point. What was your name, sorry? Mally. Good point, Mally. She mentioned sensors are in vehicles. That is true. Who drives a newer vehicle just by chance, like a Tesla, Mercedes, BMW? You could be sending your manufacturer around 200 or so data points a second from your vehicle, just so you know. But anyway, including the music that you're playing, whether your windows are down or up, things like that. Good point. Thank you. What else about vehicles would make them connected? What was your name, sorry? Lewin? Ewan. 100%. Ewan, vehicles are connected to the cloud. They're connected to the internet. Your vehicles, many new vehicles, including most public transport. What else, Saloni? Let me think. TSP, telematics service providers. So vehicles that are retrofitted with telematics devices are sending information because they're online to the OEMs, to the original equipment manufacturers. And Compass is essentially procuring that data. We get that data from a multitude of sources and we synthesize it into actionable insights. Does that make sense? So really, the bread and butter of what we do is a data set. It's a highly rich, very large data set that we work very, very hard to keep and grow all the time. So that is I think that's our secret sauce, right, Saloni? Yeah. We ourselves have no idea about traffic or transport or how to build roads or what works at all. What we do is talk to our customers and find out what they do with it. And then we build that into our tools and our visualizations so that it keeps becoming more relevant and I guess sticky for our customers. Does that make sense? Awesome. Any more questions about connected vehicles, or should we look at an example? Just go wild. Well, this is very exciting for everyone on screen and on screen. What's that? Online, in the internet somewhere. That is one trip from a vehicle. But that's not all. It kind of goes on forever. But anyway, we'll go back to the top. Each of these lines represents a moment in time that this Toyota, we know it's a Toyota, is traveling along a piece of road. We're getting the vehicle ID, which you can see in the first column is hashed, which means obscured. We don't know who this person is because our processors obscure that person's identity through the bin. We know what time it happened. We know exactly where at a point in time this person was. We know what part of the network through the lat and long. We also get some really cool variants here. We know it's a car. We know it's a Toyota 86. We know what speed it's doing. But this is where it gets super interesting. We're getting the acceleration and braking profile in G-forces. And we're also getting the left and right swerving to steering behavior. And that's all come up as values through that entire path that the vehicle travels. And times that by millions of trips a day. And that is what's happening in our cloud, Ewan. Correct. So it's just processing trip after trip after trip all over the network and road matched. So what it ends up looking like, I might choose so we're in Adelaide just for fun. We can go anywhere you like, really. But it looks like that. So that's about a month's worth of these little position events populated on the map all over the place. So as we're coming along the road, you can see that all of these little dots are, I guess, moving along at a point in time. Can anyone see those orange colored dots? Why are they orange, do you reckon? Is anyone? Ewan? Was that you? Yeah. Oh. Go ahead. Yep. Yes, some of them are. Yep. Anyone else? It's not wrong, but it's not super correct. But good try. Let's find a bit more of a. Let's find a really, yeah. Let's go to the city. Yeah, there's a little bit more happening here. Oh, there's heaps around this intersection. What's that, sorry? It could be an indication of congestion. Yeah. 100%. What was your name? Ahmad. Exactly. So this is a heat map of the top 15th percentile of G-force intensity on the network. So it doesn't mean they're braking, doesn't mean they're swerving necessarily. It could mean a lot of things, but it does mean there's an indication that in the top 15th percentile of our data set, something going on, and we're measuring the G-force. So that gives us, I guess, a sense of, yeah, what's happening on the network. And we can drill down right into all of these different characteristics. But essentially, this is a web tool that is available to anyone who uses Compass, and they can query any piece of road all the time. Can anyone think of ways that this saves time for traffic engineers and transport planners? What were they doing before this technology existed? That's true, Ewan. Yep. And cameras are in place around a lot of. What about the 10,000 kilometres of unpaved roads in South Australia, for example? Someone's got to go. Yeah. Anyone else? What does it sort of help us solve or make quicker or faster? Yeah, Luke. 100%. Where are the interesting points? So, has anyone driven over those little bumps in the road, the little lines that they put down, licorice strips, or what do they call them? Help me. Tube counts. Thanks. Again, not a transport energy. Tube counts. Who's seen that before? Yeah. Cameras, as Ewan mentioned. How else do we? Gantry. So anyone who's rich here, drive on transurban roads and you pay $10 every time you go through one of those big blue, gantry points. There's a lot of ways we can count and see traffic. And so cameras will give us absolutely everything at one intersection or one point where they're installed. Tube counts will give us absolutely everything that happens at one point where it happens. Bluetooth mobile phone data, that's a possibility. We can sniff Bluetooth and we can know where people are going. We don't know what they might be walking, they might be riding a bike, they might be in a car, but we don't know what they're doing. Whereas connected vehicle data doesn't give us everything, doesn't give us all of the different nuances of the transport that is occurring, but it does give us a picture of everywhere all at once. So like Luke said, we can straight away understand anywhere on the network what's happening. So can I take you into like a few of these examples where it can make sense, or are there any more questions at this point? No? Great. Is everyone having fun? Great. I'm just glad I found this building. But anyway, so we're in Adelaide. Like I said, I was speaking to some people the other day who said, there's an intersection here at Tapley's Hill Road where on the 1st of June, we changed the speed from 80 kilometres an hour to 60 kilometres an hour because, we wanted to make it a safer section of road. That's a very normal use case, I would imagine, in transport. Can we understand through connected vehicle data what's happened since the 1st of June? Well, I'm glad you asked because this is what we can do. So we know that it was the 1st of June, so we'll click that. Or maybe we won't. Yes, we will. Okay. Maybe we need a time range to compare it to. So we'll go with just sometime before the 1st of June. Great. And then we're just going to draw our line string from left to right. Oops, sorry. Jeez. Cool. And while that's processing, maybe we just want to have a look at the topography to get a sense of what's really going on here. Okay, we've got several lanes, big airport car park, big arterial road that's intersecting here. Okay. So on our dark pink line, can you see the 1st of June there till the 11th of September? We can see that in aggregate, vehicles are moving more slowly through that section as they go. The light pink represents the time range beforehand. We want to do 85th percentile speed just to remove all of the crazy outliers because, we're good at data around here. We can see that there's quite a significant reduction in speed of well over 10 kilometers an hour coming through that section. But what about hours of the day? So let's have a look at that. We can see that really through the daytime hours, we're maintaining speed compliance through that whole section with a little bit of non-compliance beforehand in the early hours. But once the speed was changed, traffic is absolutely complying with the speed limit. What about whether this means the intersection is performing less well or there's network sort of efficiency that's lost? Well, we can see here that we've only lost 2 seconds in travel time in aggregate. That took how long? 5 seconds to figure out. And there we go. Who here is a data scientist? Anyone? Saloni. If a good data scientist would ask, what is the sample size? She's like, I don't know. We'll get there. That's a good point. I've gotten ahead of myself. But remember how we can see swerving and braking as g-force values, remember? So let's have a look at what g-forces. So it's a straight piece of road. There's not a lot of swerving and there's maybe a little bit of braking as vehicles approach the intersection. You can see that the braking g-forces start to creep up. But remember that dark pink line is our new speed treated data set. We're seeing vehicles are braking a little bit more ahead of the intersection and far less harsh as they pass through. So all in all, top marks, our intersection is super safe. We've lost 2 seconds in aggregate from people's lives and everyone's happy. Everyone gets a pat on the back at the Transport Management Centre and we're all happy. Back to your question, Saloni, about how many vehicles are in this sample. We're seeing about 1,000 because we can see this graph represents essentially every single trip that passes through that intersection as a line, distance over time. Does that make sense? Awesome. Any questions at this point? Yeah, go ahead. Wonderful question. I did not plant that question, but thanks. That's a good one. The dotted line, because remember, we can tell whether it's a car or a heavy vehicle, right? The dotted line represents heavy vehicles coming through that section. So on this version of our, we call it road intelligence. It's meant for people like me that have no idea to be able to press a few buttons and figure out what's happening on the road. I'm going to ask Saloni to jump up in a second and explain how much deeper we can go into the data set, how much more we can extract at a raw level in terms of types of vehicles, behaviors, different things like that. But thanks for the question. I appreciate it. Does that make sense? Awesome. Great. Okay, we'll leave that for a second. I think it was Ewan was mentioning, since we have everything in the cloud, what if we were to apply algorithms or apply rules over the top of these data sets to maybe extract points or events or occurrences of interest? So one of our wonderful colleagues, Harvey, has come out with a super cool tool, actually. Let me have a look here. We'll get rid of that. Where we've done exactly that. And we call them near misses. So you can see over this map area, all of these little red dots. You saw one before when I accidentally clicked on it, perhaps. But essentially, what they represent are possible friction losses because we're seeing the G-forces coming off those vehicles. So I'm just going to hide that. We can see the trajectory of the vehicle. We can see that it pulled a positive 0.58 G-force, which is intense. Essentially, anything above a 0.47 Transport for New South Wales would deem a possible friction loss event or possible sort of ABS deploys sort of thing, depending if it's steering or braking. And we can see roughly the trajectory of that vehicle. So in this instance, we can see the X acceleration. Who remembers what the X acceleration represents? Yep, acceleration braking, perfect. Yep. And Y acceleration. Who remembers what that? Yep, left and right steering, perfect, mate. We can see that it's a Y in the positive, which means it's a right hand. Yeah, well, that makes sense looking at the trajectory of the oversteer here. So someone approached a roundabout, probably didn't brake very much and pulled a hard right. If we're seeing a big cluster of those types of events around a point, we probably know that there are issues that we need to have a look at. Does that make sense? So many more of these things are possible. This is just one that we've started to identify. Cool. So I'll quickly jump into, maybe an example of where we see near misses in clusters, but are there any questions about that at this point? Oh, great. Yeah, go ahead. So we procure it from more or less, yes, 3 sources. So car manufacturers themselves, but not every vehicle. So this is not representative of all cars or all connected vehicles. That's the mission that we're on, is to try and keep building our data set. We collect it from public transport vehicles. So Transport New South Wales, whatever the relevant state authority is doing. And then we also get ferries and trams and buses, by the way, trains, which we don't use, but and then telematics service providers. So a lot of heavy vehicles, a lot of fleet vehicles are retrofitted with a tracker, like when you go hire a car from Hertz, so that they can see what you're doing. We work with those companies as well. No. It'd be amazing if they did, but no. No one gives anything for free, and especially data. I think, who's worried about their phone passing on data to Lord knows who? So you always click ask app not to track. Yeah, exactly. I think people are generally like that. So if we're procuring data, it's not easy, and a lot of the time, it takes a lot of convincing. And it's why it's very important to obscure people's VIN numbers and identity. Yeah. We don't. It's a great question. We get it all the time. It would be good to try and figure that out. We're trying to work with the Federal Chamber of Automotive Industries, the people that regulate from the federal government side, regulate the sale of cars and report on that. It's just such a lag in reporting statistics. Yeah. We don't. The only way we know our coverage is really the best way we know it is through Transurban. So we work with Transurban. I should mention we work with every state government in Australia, many local governments, including Randwick, including City of Sydney, Waverley. And so Transurban will tell us from their gantry points, they'll be able to count and compare that against Compass vehicles. So that's a raw comparison. We don't actually know which vehicles are connected as they pass through. Or we're starting to be able to figure that out now. Yeah. So yeah, we're seeing at any given checkpoint, sort of 3 to 5 to 8% of the network is connected and in the Compass data set. Yeah. I think the best way to, if you're on the transport authority side, I think the best way to figure that out, oh, whoops, I don't know what I've done here, is to go through to that count page where you see the sample size of vehicles. And again, it's not everything. We go through a rigorous data cleansing process, and maybe Saloni will touch on that. I'm not sure. Really quickly, because I've been going for 11 minutes now, I'll jump over it. So, who's ever heard of glow roads? Anyone heard that before? Yeah. Do you know what it is? Yeah, I think you're right. I've actually never seen it. I've just heard about it for the first time, I think, on Tuesday. So so the problem that we're trying to solve here is that there's a lot of regional road in Australia and in all the different states. We can't put street lights everywhere. It's very, very difficult and costly to make these roads safer. One of the biggest road safety concerns is single vehicle accidents or multiple vehicle accidents on regional roads. And so how do we make that? How do we solve that problem essentially? And so there's a team that approached us the other day and said, "Hey, we are looking at areas on the network where we're seeing a lot of near misses, particularly around bends in regional areas, and we're trying to prioritize those to treat them with this kind of glow road emerging technology, which I imagine is like not powered. I think it's probably some sort of yeah. Similarly, has anyone been to Manly and seen the 3D crossings? As you drive up, it looks like a 3D block coming out of the road. There's all of these sorts of really cool ideas. Yeah. So we had a look. They had an area that they wanted to test out, and sure enough, we're seeing a big old nest of near misses over here. Is anyone familiar with the Bulli Pass? This road, by the way. So we're in just south of Sydney. Yeah. Who rides a motorbike? You probably would love going down roads like this. Yes. Whoops. I've completely lost it now. Better type it in. Yeah, I think I've gone too far. You're right. Wonderful. Okay. So this piece of road, you're coming down a hill, a big escarpment, and you're swerving left to take the corner, and we're seeing just a lot of activity there. So perhaps we'll do that whole thing again where we select a path. Remember, we're going downhill at this point, and just have a look. Whoa, crazy. We go in satellite, the road disappears because it's covered in trees. So that's more context for us. A lot of obscuring of vision. Okay. So, the speed over distance, that all makes sense. Vehicles are going, we'll probably put heavy vehicles in just for fun as well. Vehicles are taking that corner very slow. That all makes sense. But what really is crazy is, remember, this is an aggregate sample of G-forces. So particularly cars, heavy vehicles are probably taking it with a bit more caution, but cars are taking that corner. And in terms of G-forces, we're seeing super concerning numbers here. Just have a look at our sample size. Yeah, about 500 vehicles in that one. So remember, this is aggregate. So every single vehicle essentially is taking that corner too hard. So straight away, we're able to see that that section of road is definitely something we should be looking at more. If we want to, yeah, maybe have a little bit more of a look at the street view, we could do that as well. Again, oh wow, safety ramp. Yep. So that's where the heavy vehicles go if they run out of steam or have too much steam. I don't know. But yeah, crazy little bend there, little hairpin bend. Any questions about that? But again, a few seconds, and we were able to say that's exactly right. Your suspicions are founded. We should definitely treat that area. We've got a representative sample size that can be used, and we can make a decision. No one has to drive out, put strips on the road, put cameras on the road, anything like that. We just know. Cool. Saloni, I might ask you to make sense of this a little bit more. Oh, Ewan, yeah. Great question. So yeah, if you were to look at a Telstra coverage map or something like that, there's a lot of regions that aren't connected. Some vehicles will sort of send data to the cloud once they're back in coverage. We're seeing a lot of mine sites, for example, out in Western Australia, South Australia, where vehicles disappear for a long period of time, and then sort of there is data coming back. One of the cool things we're doing is monitoring the unpaved road speeds just to see whether roads are serviceable or not, just from that connected vehicle data. But yeah, we lose a lot in regional areas. So again, the sample size reduces. If that was a street in Sydney, we'd be seeing 20 times the volume probably. But because we're, maybe only Telstra or maybe a little 4G covers that spot, we're not seeing everything. Yeah. Yes. 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 100% possible. Like you can do it yourself. Yeah. 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 Awesome. Yeah. Go ahead. Yes. Yes. 100%. We're seeing that in Tasmania, South Australia, where they don't. South Australia, particularly, who owns a car here, by the way? If you own an older car, you know that every 5 years you've got to. Is it every 5? No, if it's 5 years old or more, you've got to take it in to a mechanic every 2 years to make sure you get a blue slip, I think. Okay, clearly I know what I'm doing. I think I just send it to the servicing guy and he just sorts it out. But yeah, you really should be on top of your maintenance and making sure your car is roadworthy. In some states in Australia, that's not the case. There's no legislation, which means that yeah, people are going around with very bald tires, very much older cars. Yeah, for us, I think. And Saloni maybe can touch on this if you want to, or we can certainly answer this question. We go through quite a data cleansing process to remove outliers. So we lose a lot of our data because of that, but it's in the pursuit of accuracy, I would say. Yeah. Yes. Yep. Yes. Yeah. That's a great hypothesis. We would not be able to help you with that because we can't tell you who is driving which car. Yeah. But it's a good hypothesis. I'd love to know if Ford Ranger drivers are worse than Hilux drivers, but yeah. 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 Yeah.
Same access the lifetime of the vehicle?
No. It's a good question. So for privacy, we what do we call it? We switch.
ID rotation, and depending on our telematics service provider, it rotates. So some rotate every some rotate depending on depending on the TSP, there's vehicle ID rotation to maintain privacy.
So you can't really track
No.
one vehicle?
No.
Even like
We can, but that's a whole other product line.
Not yeah.
Yeah.
But we do prioritize privacy a lot.
Yeah. Cool.
Oh, thanks, Dave.
Leave that.
Okay, sure.
Yeah.
We have plenty of time.
Yeah, we do.
Can I see me okay? I don't know if that's right.
yes.
All good?
Yes.
Okay, so thanks to Dave for the amazing introduction. And that hopefully gives you a bit of context about who we are and what we do, but I'll dive deeper into what we exactly do. So before I begin, hi guys, I'm Saloni. How's everyone feeling after the first presentation? Yeah, good. Great. So I'm a data scientist here at Compass, and my main role is to understand and solve complex transport problems with connected vehicle data. And today I'm going to talk to you about how powerful connected vehicle data is and how you can leverage it in your own work. So today I'll be splitting up my talk into 3 little sections. Firstly, I'll be telling you more about Compass, what we do, who we are. Secondly, what we do, and thirdly, how it will benefit everyone in the room today. But also a bit of context, I'm studying a Bachelor of Engineering majoring in data and a Bachelor of Creative Intelligence and Innovation at UTS. So that's just a bit about me, and I've been at Compass for just over a year now. So, yeah. So on to the first part of my presentation. Who are we? Compass IoT is a multi-award-winning road intelligence company which uses connected vehicle data to help transport professionals build better and safer cities. But before I get into all the fun stuffs, in addition to what Dave has showed you, I want to unpack this statement a little. What do I mean when I say connected vehicle data? Now, I assume that everyone now knows what a connected vehicle is, but I'll say it again for those who missed out. So, in simple terms, a connected vehicle is one that is capable of connecting over wireless networks to nearby devices. The internet connection allows for data to be transferred to the cloud and then to us. And in simple terms, we like to call it the 3 C's, from car to cloud to computer. Everyone got that now? Yeah, great. Every connected vehicle sensor provides granular pieces of information, which is more accurate than a regular database, and provides more information that we can be provided via hardware or plug-in devices. The reason for this is because this capability comes straight from the car's brain. The granular information, which I will go into detail later on, paints a detailed picture of driver behavior with data updates every few seconds from each vehicle through continuous data pings. Now, onto the second part of the statement. What do I mean when I say better, safer, and more resilient cities? Well, it means using data like braking, swerving, G-forces, speed, and location to make dynamic, proactive, and informed decisions about how drivers use our road infrastructure to get from A to B, and making sure they and those around them do so safely. Compass has data for virtually every single road across Australia. This includes urban centres such as Sydney or Melbourne, all the way out to Alice Springs and in between. We are also expanding our data sets across New Zealand, UK, and North America. David did go into this, but we do get speed, predicted volumes, braking data, swerving data, roll, pitch, yaw, Z-axis, travel time, vehicle make, model, all that fun stuff. Does anyone have any questions so far? Yeah, we're good. So, we use connected vehicle data to generate greater insights into how people actually use the infrastructure versus the way we've designed it to be used. Honestly, I find this data so cool because we can do so much with it. And I'll go into what we do. I'm going to go through a few cases that me and my data science team work on a daily basis. Again, this is a very high level snapshot of what we do, just to give you a better insight on how unique and diverse our data set is. So I'll be going through safety and near misses, speed analysis, origin, destination, and predictive analysis. But before I get into that, David explained our road intelligence platform. Here, our data science team has custom queries from our clients, which go into a granular level of detail. We can filter, we can do all sorts of stuff. So yeah, this is the first use case that I want to present to you. This is for UNSW, and they wanted to understand safety at school crossings, including near misses, harsh braking, and speeding data. So specifically, they were interested in all of this, and we use a 200-meter buffer on either side of the several crossings that we got. This data set includes state and non-state schools in Greater Sydney. And yeah, so our solution to this problem was a dashboard that showcased data collected on school days during school zone hours, and that can be filtered again using 200-meter distance. The dashboard also displayed trip counts, overspeed percentage, harsh brake counts, and harsh brake percentages. And you can also see over here that there is a nice heat map of all the points that are overspeeding and braking G-force with the labels as well. And here on this dashboard specifically, we used a harsh braking of greater than 0.3 G, which we consider very high. And also the overspeeding count here can be filtered by the user as well. So for example, if the car is going over 10 kilometers, 5 kilometers, 4 kilometers, whatever the user wants. So yeah, any questions about this dashboard? Yeah, cool. Yeah, before I continue, I do want to again explain what a near miss is for those who missed it. A near miss is a rapid evasive maneuver, either braking or swerving, to avoid a crash. It is a leading indicator of road safety risk based on swerving and braking behavior and a G-force reading. It is where drivers are losing friction of the road. But I do want to emphasize that a near miss is not a crash and needs to be considered in the greater traffic context as to whether the results are actually dangerous to drivers. So that's very important. It's not a crash. But yeah, just adding on to the UNSW dashboard, we were also able to identify the top 8 schools or top schools. And as you can see, Alzara in Arncliffe has 3 near misses and their high speed and total G-force. So it was an aggregate result over all the data set. And then we also have the near miss location, similar to what our platform does, but just on a, I guess, more detailed level. Again, you're able to filter out G-forces and all that stuff because we provide you guys with filters on the dashboard as well. Everyone good with this use case? Yeah, sweet. Now, another interesting one was done in UK. Here, the client also wanted to understand the top unsafest roads near this section in London. So I think you asked about like restricting the area, so that can be done through the data science way, and I think it provides you with a more granular data set as well. And as you can see, all the filters up there, we can provide you with practically anything related to our data. So yeah, you can go through year, month, hour intervals, OSM IDs. OSM ID for reference is OpenStreetMaps. That's what we use to road match. And we also use Valhalla as a road matching software. So yeah, we get access to all the road network. You can filter by near miss classification, vehicle type, road type, speed, braking, swerving, G-force, intersection flag. We can also identify intersections. That's pretty useful for someone that wants to look at just intersections of the highest, what's the word? The most busiest intersections are the ones that have the most G-force. And then we also give you near miss count, braking count, and a nice heat map of the network, near miss count, and also total G-force. And then again, a table indicating each individual OSM ID and OSM network, and then the aggregates for that. Everyone good with this use case? Yes?
What are those little boxes that you have on there? Top left?
Yeah.
Can you play around and add or customize in whatever you
100%. So this is all customized. Every use case that we get, we customize it as per the client's needs. I will go into more detail and show you an actual a live demonstration of one of the dashboards that I did for Sunshine Coast. But yeah, that's coming up. No worries. Yeah. It's very important because everyone has different business problems, I guess, and we really want to ensure that they get the most out of our data set. For example, I'll go back to that one. You might not be interested in OSM ID. Maybe you want like a higher level view of what's happening. So maybe we won't break it down by OSMID or road networks. We'll give you like an area and then aggregates for that. Or maybe you're interested in vehicle ID. Like sometimes what we do is we give the vehicle ID and give all the information corresponding to that vehicle ID only. So it's really what you want to get out of it. And we try to deliver as best as we can. Did you want to add anything? Oh, sorry.
We just don't know what problems really need to be solved, unless customers tell us.
Yeah.
But it doesn't take a lot of work. Saloni makes it easy. It takes like a week sometimes.
Yeah, but I think it's really we just want to cater towards the clients and make sure they're getting the most out of our data sets, to be honest. Yeah, next one. This one was quite interesting. This does show how powerful our data set can be. So this client, again in UK, wanted to identify and compare post and pre and post implementation. I think they changed they had some road closures or something. So as you can see, on the left-hand side, we've broken down this OSM ID map by average speed, and here we've done travel times. So you can really paint a picture and see what's actually happening before and after, and see and evaluate if your implementation has been successful or not. One use case that is super cool. And then I think here, does it go? Oh yeah, again, road time. And we can even do school traffic period, filter out for like 8 a.m. to 4 p.m. I think it is, etc. So we can filter out the time period. We can take it down to like hour level data as well. So, or seconds, whatever you want, basically. Yeah, anyone have any questions about this one? Is it interesting for you guys to learn about this?
I guess the point is you guys can get directed. So
yeah. There's obviously more that we can do, but this is just a high level snapshot of interesting ones that I think you might like. Yeah, so this is back to your question. This one was quite interesting. I don't know if you can see the red little markings. So Sunshine Coast approached us and was like, look, we want to implement some road closures down here near Bowman Road and up there near like Mary Regent Street. So they really wanted to understand how people use this main road and how many people are taking the left turn, right turn, going straight, etc. So they just really wanted to understand driver behavior over here. And for that, we created this dashboard. So here we can also filter out by SA2, suburb, etc., like LGAs as well. Start road, start direction, end road. Yeah, these are the roads of concern. This is using Edge IDs, which is Valhalla. Yeah, so these are the roads they cared about. We provided them with all the trips. So as you can see, the legend over here. So the trips that are going from Sulla to Bowman and Park to Bowman, whatever they wanted, basically, the combinations. And then when we scroll down, you can see, again, Sulla Street to Bowman Street, westbound, and a number of trips. So this data was really useful for them because they understood what people were doing and how many people used that certain turn, which they were able to make an informed decision if they wanted to go ahead with the road closures or not. And we can also filter by starting suburb. So if I just hover, it tells me where most trips are starting and ending. We can also customize the tooltip to like vehicle counts and stuff to give you a better understanding of how many trips are starting and from where, etc., etc. And if we scroll down, we have ending suburb, and then here we have origin destination by suburb. So most trips that were going from Sulla to Bowman in the westbound direction started in this suburb and ended in this suburb, which we like to call a round trip, started and ended in the same suburb. Everyone good with this use case? Am I going too fast? Everyone getting it? Sweet.
Was this use case about wrap running as well? Like
yeah, a bit. Yeah, I think that might be a different one. Yeah, mainly road closures. Yeah. Okay.
A lot of customers get it. Explain wrap.
Yeah, sure. Let's take this this street for example. So you know the long main road here, Regents to Bowman. So let's say it's very busy. Some people might like, and feel free to jump in. Some people might take this and then go here and then take the smaller roads to go back onto the main road. That's my understanding of rat running. So basically like avoiding traffic. Yeah, detour. Yeah, yeah, yeah. Yeah, exactly. And it's pretty cool when we do analysis for rat running to see like how many vehicles are using residential roads and stuff. But yeah, this wasn't rat running. This was just purely seeing road closures. They wanted to implement that. So yeah, moving on. This one is probably one of my most favorite use cases that I'm presenting to you. So the client wanted to identify speed bumps around Botany, and one of our data scientists came up with this algorithm, like David was explaining before. So we use Z acceleration. Does anyone remember what ZAC is? Oh, okay, I'll go through it. ZAC is basically the up and down movement, which also gives you an indication of road roughness. So potholes, cracks in roads, etc., speed bumps, for instance. So yeah, Angus developed this algorithm to identify, and it's pretty accurate actually. So ideally, if you like drag that little man over to one of the red zones, you'll be able to see a speed bump there. And the way he did that was using ZAC and the standard deviation. The first map goes through potential speeds and the second one goes to surrounding speeds. So he used a combination of ZAC and speed to determine speed bumps, which is pretty cool. And it also shows that we can use like models and other values to really like identify cool things on the road network.
I remember like when we were working in Geelong, yeah, they didn't have data about when they installed treatments. They didn't actually know. So it's another cool way to use this.
Yeah, and you can, again, if you pair it with like before and after implementation, you can really, I think this is what they were doing. They wanted to see like if the speed bumps were working or not, if people were slowing down, etc. Sorry, you had a question? Yeah, Botany. Oh, my bad. Sorry, yeah, my bad. That is Melbourne. You're so right. Yeah, sorry about that.
But now we've got America, the UK, and everything.
Yeah. Yeah. No, because initially it was for Botany, the test case, and that's why Botany was in my head. So sorry. Good pick. Yes. Yeah. Yeah, great question actually. So that's based on the ZAC value. So if it's either going down or up, and we can identify based on that. Yes, essentially. That's how we identify swerving and braking as well. Hmm. Yeah. Yeah. As in, what do you mean?
Some authorities do.
Yeah.
Yeah, they
Depends.
use data to sort of like identify maintenance spots.
But yeah.
The main one is Transport's asset AI program. Do you want to explain that, or do you?
I'm not too familiar with that one. Yeah.
Yeah. Big Dave. Okay, so it's a multimodal project. But what we should say is that Compass works very well in multimodal, multi-input data projects. So Transport is using Compass data to scan the network and to see where, like in a heat map sense, where things might be worth investigating. And then they send LiDAR, which is, are you familiar with LiDAR? Yeah. To scan and understand pavement condition. Then there's sort of a, I guess, a prioritization algorithm that tells them, which sites need to be prioritized. So it becomes part of that, but it's also
yeah. I forgot what I was going to say. Oh, good. Yeah, so in addition to the heat map stuff, we also provide them again with a table of data. Here you can see line strings. This provides you with the exact line string of the vehicle, oh sorry, the section ID in this case, but we can also provide the exact line string of the trip. So yeah, yeah, pretty cool stuff. Any questions about this? No? So my last section of my presentation is what's in it for all of you. As research students, traffic engineers, transport professionals, leveraging Compass IoT's connected vehicle data means gaining access to highly granular and real-time insights that you can use to make informed, smarter, safer, and more efficient transportation strategies. Whether you're analyzing driver behavior, assessing road safety, or evaluating the effectiveness of traffic interventions, our data provides you with a more nuanced understanding of how people actually use these roads. So like imagine having the ability to pinpoint exactly where near misses are, or even occurring around school zones, or even identifying the most hazardous intersections across the entire city's network, or even the opportunity to evaluate the success of your traffic schemes based on real-time data. Sounds pretty cool, right? Without like very labor-intensive activities. But yeah, by collaborating with Compass IoT, you not only gain access to our data, but also a partnership that empowers you to make more informed decisions, validate your research, and ultimately contribute to the creation of a safer and more resilient transport network. We're really excited to hear how you guys can use our data and if you guys are interested in it. But thank you so much for listening to me and Dave. And if you're interested, you guys can scan our QR code, hopefully that works, and check out our Learning Hub. Thank you. Thank you. Oh.
Dave, perhaps you can, sorry. Yeah, can you also talk about the coverage of your data, because it's not only actually as a speaker.
Yeah.
Can you expand on it? What's the coverage of
North America, the UK, New Zealand. That's everything, right?
New Zealand, North America, yeah.
Yeah.
And Australia.
Yeah.
And in terms of like, for instance, the sample size, is there any difference that we discussed it, for instance, in Adelaide or Tasmania, you have more, less sample size perhaps?
Yeah.
It could be also less traffic. That
Yes.
could be the reason. But also even like in terms of actually when I was looking at different kind of data points, I was wondering that, for instance, have you looked at if the sample size in some suburbs in Sydney they're less? So assuming that the data basically comes from the SIM cards, basically in the cars and the newer cars.
Yeah.
If you can see less number of data points in some suburbs, could it also mean that perhaps they don't really have new cars? Is that something that in terms of equity can be?
Yeah, I mean it's definitely yes. Is the short answer. I can't find. I'll have a look if I can find him. I don't file things very well. The last output from Transurban showed the M2 had the most volume for us. I think someone mentioned before about coverage. So who would know which roads in Sydney have the least coverage? Okay, that's all right. Tunnels, because we lose our So we're working out ways, but we're not entirely sure. So with all of the new M8 and all of the tunnels going on, we were getting some funny looking trips come out of those. Also Uber drivers, we love them, but they take 12 hours to get from Bondi Beach to Randwick sometimes, and you're a bit like, why is this trip skewing the entire data set? And you realize it's someone on a shift. So there's all sorts of problems, I guess. Yeah. Yes.
Thank you. To avoid these outliers, so there's extensive filtering that goes on. Again, like David mentioned, we might lose some data in that, but we just prioritize accuracy over everything else.
Regarding your database, how rich your database is in the regional areas of the New South Wales, to be precise. You know that the case study about that, a school zone in the New South Wales, in Sydney, sorry. I kind of had the impression that you had a good database around the Sydney area, metropolitan.
Yeah,
But I was, curious to know your database also in the regional areas.
we don't know unless we try.
Mhm.
That's the truth. Especially with remote roads, one really good, probably my favorite thing we're doing at the moment is the unpaved road stuff. Because for this SA government, it costs them so much money to send a contractor for 10 hours out into the middle of, near the border to the Northern Territory to see if a road is working or not, if a tree's fallen over, if it's flooded. And so they will take one trip from one car in a 1 month period as a sign that they don't need to send anyone up, so it's interesting how you can frame stuff and slice and dice it. But yeah, we just wouldn't know. I might just do one now. Yeah. Oh, yeah.
Good question.
Yeah. Yeah.
For again, school stuff and like other driver behavior in regional areas.
The question I have is about the rail corridors. Can you do the same analysis, or do you have that same experience in the rail environment as well? For instance, that seated, just analyze the train speeds, that the train driver behavior kind of a thing.
Oh, we don't do anything with our train data yet. I think it's probably out of scope for us, hey?
You just focus on the road network.
What we have in terms of rail, what we've done is sort of analyze level crossings, so where vehicles are interacting with level crossings to see sort of harsh braking and swerving in a similar way to Saloni's example around schools. Yeah. We lost a bid to do something on that with whoever it was, a federal government department, probably an iMove thing. Yeah. Okay. So here's the Newell Highway, pretty major road between Narrabri and Coonabarabran. Has anyone been? Not me. Yeah. So what we can do, if we're not getting enough data, it won't process. Yeah. So what we can do is extend the line string a little bit. See if that helps. Yeah.
So may I also invite Associate Professor Miad Sabri. Miad, sorry for putting you on the spot, but that would be wonderful also if you explain a bit what you do in your courses, what data you are using, and what do you think would be the use case for the Compass IoT in your teaching?
Cool.
If you're done, let me show you. I want to show you a bit of history because I don't know. I don't think even if Dave and Saloni knew about this experiment.
Yeah,
From 2008. Before any connected data was out there. So for those of you, so again, for Saloni and Dave, I teach a traffic course here at UNSW, which we don't use Compass IoT. I mean, we can use Compass IoT from now on, but before we weren't using it, but we've been using other data, mainly from the US, which I had access to, looking into vehicle trajectories and things like that, like the GPS tracks. But I think this would be very interesting for many of you, I'm sure. So now that you know what connected vehicle data is, imagine 2008. None of the vehicles were connected, okay? But some of you, maybe not, hopefully many of you, are too old enough to remember this phone. Do you know this phone? Anybody knows this phone? Nokia N95. That was one of the early phones that was equipped with GPS, okay? You can buy it on eBay today for only $54 compared to your iPhone. Okay, USD. Yeah. So back in 2008, UC Berkeley conducted an experiment. It was called Mobile Century initially, then they expanded it to something called Mobile Millennium. So what they started with was they hired 10 cars, they hired 10 students, they gave each student a Nokia N95, and they asked them, hey, just drive around San Francisco. And what they were doing, they were collecting exactly what you say 15 years later. So this was, at the time, none of the cars, even Benz and BMW, Tesla did not exist at the time. So I'll show you how it looks like. So anyways, that was done in February 2008. Then later in November, they released it to the public. So they ran the experiment for about 12 months, and about 5,000 people in the Bay Area downloaded their app. It wasn't an app, it was a software download under Nokia N95, because again, Nokia N95 is not a smartphone. There was no app at the time. So what they ended up doing is a very similar coverage to what Dave and Saloni was showing. And interestingly, going back to that sample size question, they actually showed 3% of the cars being connected is enough to get a very complete picture of traffic around any area. So anyways, that's the data we use in one of my courses in UNSW. And if I show you, very similar to what you were talking about. So we look at trajectory of the vehicles coming from those Nokia N95 devices, where they slow down, where they speed up, acceleration, deceleration, etc. And then we plot things like that, which you guys probably do and familiar with. This is the time and space diagram where we see where congestion forms, or when every bunch of vehicles slow down, we see where the congestion happens and things like that. Anyways, that's the kind of things we go through every year in one of my courses, but it's 9422. Some of you might have taken, I see Deepthi. Anyone else other than Deepthi has taken 9422? No? Anyways, an opportunity to take it next year if you're interested. Anyways, just wanted to give you a background about some interesting historical developments in connected vehicle. Yep, that's it from me.
Okay, great. So let's start. Again, thank you for staying with us for the second seminar presenting by Luke and Mason from UGL. So Luke actually has traveled from Devil to here last night just for the sake of the seminar.
Wow. Demo.
Yeah.
Yeah, such a great. Oh,
It's about 5 hours to the west of here, so yeah. Lovely, lovely place.
so hopefully, I'm pretty sure that hopefully I'm pretty positive that we will get lots of insights from your presentations, guys, and we're gonna experiment that actually how we can collaborate later. So there could be some research projects that, or any interesting points that you may want to kind of tackle your research projects or your honors projects, or as a side project, applying for, again, taste of research. So you have my contacts, and also we can discuss this further and fine tune the research topics. And without further ado, I leave it to Luke and Mason. Thank you.
Thank you. So yeah, we probably drew the short straw by going second. I don't think we have quite as sexy a presentation as the Compass guys, but so what we're going to talk to you today, I'm going to give you a bit of an introduction, who Maysam and I are and why you should care what we have to say. What's the country regional network that we work for? What do we do? What are the key threats and opportunities facing our network? And then we're going to have a bit of an open discussion about how all of you guys can help. This is me and Maysam. I'm the head of assets and engineering at UGL Regional Linx. I look after a department of about 35 people, most of them engineers. We have a mixture of different engineer types. Personally, both of us are civil engineers, but I look after electrical engineers, telecommunications engineers, rolling stock, mechanical, etc. as well. And Maysam is our principal bridge and structures engineer, so he is the peak technical authority on anything to do with bridges and structures within our organisation. So me, I've got about 17 years experience in industry. I studied at the University of Wollongong. I have a Bachelor of Civil Engineering. I started my career at Railcorp, which later became Sydney Trains in about 2006. I joined John Holland when they won the contract for the network that we work on, the CRN, when it initially went to the private sector. And I went for a 1-week secondment to help them get started out, and I'm still here 15 years later. I've worked for the CRN ever since the John Holland contract finished. UGL picked it up after that, and I've held a lot of different roles, mostly on maintenance and asset management, and most recently engineering leadership. Maysam also has 17 years of experience. He has both a Bachelor of Science Railway Track and Structures and a Master of Civil Engineering Marine Structures. He's got a mixture of experience working asset management, design, consultancy, engineering leadership, both in Iran and Australia, and also brings some marine structures experience as well into the mix, which was part of why I hired him, actually. And the link between that, interestingly, is that both marine structures and our network are probably some of the largest maintainers of timber structures in Australia. So that was, it's a rare skill to find, to be honest, in a civil engineer these days. Most people know how to work in concrete and steel. So Maysam brought with him some timbers experience. So let's talk about the network that we're here to talk about. This map here is a map of all of the railways in New South Wales. The easiest way to describe the CRN is it's everything that's not Sydney and everything that's not the ARTC interstate lines. So ARTC is a federal government railway that connects all of the capital cities in Australia. They have interstate lines. They're a federal government initiative, as I said. And then each of the states typically has a metropolitan rail entity and somebody that does all the regional lines. So we do the regional lines in New South Wales. Most of our network is an origin point for freight. We're primarily a freight network. We do have some passenger traffic as well, but we service grain, minerals, coal, general freight, etc. So often the trains are loading on our network and then we feed them into other network. And we have a pretty extensive portfolio of infrastructure, 2,300 kilometres of operational railway lines. We look after a substantial portion of what's called non-operational track, but it's basically closed track that's on you know, they haven't decided to suck up the political will to tell people that it's not coming back yet. We're actually the third largest manager of land and property in the railway owns a lot of property. It used to own office buildings, depots, other miscellaneous properties, much of which is leased out these days. We have a lot of level crossings, interactions with the road network, and a significant portfolio of road over rail bridges, including not on our network. So we look after the road over rail bridges on ARTC's network as well. So why does our network exist? Well, we do have some passenger traffic. So most of the regional cities have some kind of passenger service, 1 to 2 per day. Pretty low patronage, pretty low if you compare it to, say, the Sydney network. We're probably talking about moving thousands of people per day rather than hundreds of thousands or millions. Those things mostly exist for political reasons, to be honest. They don't compete very well with other transport modes. We have a pretty extensive heritage passenger involvement, steam trains and all that sort of stuff that still run around our network, which is very interesting, trying to make steam trains from 150 years ago fit modern standards. As you can see, bulk grain is one of our big, in terms of annual net volume, probably our largest. That's a mixture of domestic consumption. So any of you that eat any product that is made from wheat flour probably came from our network. We about 50% of that grain is for domestic consumption and goes to many of Manildra's plants around the state, and about 50% of it goes to export overseas. Plus there's a lot of non-wheat agricultural products in that mixture as well. general freight, again, often from factories in regional areas that gets containerized and then often sent to the capital cities, some of it for export, some of it for internal consumption. Bulk minerals, in New South Wales, it's much more likely copper, zinc and gold than anything like, we don't have iron ore here in New South Wales, so it's distinct from, say, Western Australia. Bulk coal, all of the coal power plants in Newcastle and Sydney are powered by coal that begins on our network. And I mentioned the containerized stuff. And there's occasionally some special purpose trains as well. The military occasionally moves tanks and aircraft around via the rail network. And we do occasionally have things like transformers for energy projects can also come by rail. Yeah, so we actually look after the first mile much more so than the last mile. So in a lot of my experience at the moment, the multimodal thing everybody's thinking about, the last mile at the moment, that's very, you know, very topical. But we usually do the first mile. If you go back to anywhere before the 1990s, the whole network's purpose was to act as a collector for Sydney and Newcastle and Wollongong. Almost all of the commodities markets were regulated. If you mined or grew it or produced it in New South Wales, you could not export it except from the ports in New South Wales. So everybody had to send it to Sydney. After deregulation in the early 90s, that's not true anymore. And we do face a lot more competition now from road market share where take the north of the state, it is a nearly 22-hour journey to the Port of Newcastle, or it's 6 hours to Brisbane. So we don't currently have any lines that connect the areas that we do to other states very easily. So that's part of the challenge for us at the moment. We mostly feed into ARTC or Sydney trains. So they're our two biggest networks that we feed into. So yeah, depending on the destination, interstate or Newcastle probably goes on to ARTC. If it's going to Sydney or Wollongong, it goes on to the Sydney Trains network. And an interesting thing about our railway is that most of the towns along the railway were created because the railway came through there. So we have quite a lot of urban centres centred around our railway because they were the lifeblood of it when those towns were founded 150 years ago, but they have grown substantially, and urbanisation and the constraint of having a massive railway through the centre of some of these places does cause a lot of problems. So about our network, it's a bit of a museum compared to, personally, I find the metropolitan networks to be pretty boring. They're all very homogenous infrastructure. They're all very good infrastructure. From an engineering perspective, I think they're very conservative. We have some rail on our network that's original from when it was laid in the 1870s. 60 pound per yard rail looks like the stuff you would see in like a museum, like a toy, you know, the little toy railways you get in museums. When I first came out here, I couldn't believe we ran trains on it, but we do. We run freight services on that. And we still have a lot of jointed track, which is not common these days. We have operational turntables, so steam trains typically only go in one direction. So back in the day when steam trains ran around, they had to have turntables everywhere. We do still have a few operational ones around, and they are mostly used by heritage passenger services because the diesels can run in either direction. I should say our network is not electrified at all. It's entirely unelectrified, mostly diesels. We've had to modify these for longer trains as well because this may have once taken a very small steam train, and the heritage people have largely sourced bigger steam trains from around the place. So trying to upgrade an 1845 wrought iron turntable for modern trains is interesting. This is an operational line, by the way, what you're looking at. We have a lot of seasonal grain lines. So this is a line that is only actually used not every year. So it's in the north of the state. Some of our lines only come online when there's a big harvest, and then the operators will switch from a road transport mode to a rail transport mode when the freight task gets above a certain time. And we do extremely minimal investment in these lines to justify their existence. So for us, that extremely minimal investment is really important. Spending $1 in the wrong place is a really bad thing for us. We try to judiciously spend our money. We have a lot of redundant infrastructure. In fact, we have more redundant infrastructure than we have currently operating infrastructure, and most of it was abandoned around about the same time between the early 70s and the early 90s. There was no strategic plan for its removal, and it has started to get to critical levels in some areas, and everybody's forgotten about it. So in this particular photo, this was a grain pit. So there's an auger underneath there that feeds into a silo. So once upon a time, the trains would have come here, they would have dumped grain into the auger, it would have fed into the silo, and it was probably sold locally to mills and farmers and that sort of stuff. But the infrastructure's not been used or maintained for a long time. We also have a lot of heritage structures. So the one on the top is the Gundagai Viaduct. It is a national significance heritage timber bridge, 60 plus spans, that has been non-operational since the 70s, and we still have to look after it. So as you can imagine, thankfully it's in an alpine environment, so the timber isn't as bad, but we have a significant portfolio of timber bridges that were made into heritage assets in the early 90s without much of a plan about what to do with them. In some cases, not with Gundagai, but with other ones, the timber materials are not even, you cannot cut down hardwood in large enough sizes to make them members of some of those bridges. So we are struggling to keep them standing. We also look after a large portfolio of dams because steam trains needed them to re-water. They're largely now completely useless to us, but we still have to look after them. So they've had very minimal investment. Often they're used, leased out to local use like quarries and local town supply and that kind of stuff. We definitely have a lot of issues. So this is all mainline operational track around the network. This is just a few of my own photos from travels around. I realized at some point you guys can take this as a life lesson as you go around. Whenever I put one of these presentations together, I realize I only take photos of the bad stuff as I go. So occasionally I have to find a good example of a representative area of our network, and I almost never can. So take photos of everything, not just the bad stuff. That's a good bit of advice there. But we have very poor drainage on our network. A lot of the network was built outside of Sydney to American standards in the 19th century, which the Americans at the same time were racing to connect the two sides of their continent. It was mostly driven by private investment, not government investment, and it was to an extremely poor standard without much thought to the long term. So when they got over the Blue Mountains and switched from a British standard where it was very slow, considered deliberate formation, the American standard was just lay it on the mud and worry about what happens afterwards. So a lot of our network has very bad formation and ballast and is way too expensive for us to tackle in the ways that most other railways would. So in a big metropolitan railway, if you're in the city, if you were in Europe, if you were in a really high utilization one, you would pretty much just reconstruct that from the ground up. You would start again. You would rebuild the formation, etc. We can't afford to do that. It doesn't make any sense for us. So we're always looking for innovative, low-cost ways to get as much of the benefit as possible. You know, the old 80-20 rule. Can we get 80% of the benefit for 20% of the cost? That's how we get by. A lot of our network was built using secondhand materials. So over the last 20 years or 30 years in particular, the Sydney network has almost, I mentioned it's very homogenous. They pretty much ripped everything out and put the same new stuff of the same configuration everywhere in Sydney. The stuff they ripped out didn't go to the scrapyard. It mostly went to our network. So we replaced smaller rail in particular with secondhand stuff from the city. And often it was completely stuffed when it was pulled out. So, but we still managed to give it extra life. But we do have a regime that's dominated by defects rather than wear. So that requires a totally different kind of thinking to manage the growth of defects rather than we would like more wear that would give us less defects. We've had a lot of jury-rigged repairs and off-design solutions over the years. The people on the country rail have been very clever and they've come up with a lot of innovative solutions. But it means we have dozens and dozens of configurations for every asset type. There's not a lot of standardization. We often don't have the original design records for how these things were designed, if they even were designed and weren't just built in somebody's workshop locally. That can be especially challenging. So we're often called upon to judge what can this handle. You know, this level crossing here, say somebody wants to start running B-double trucks into a grain silo or something across that. Can it handle it, or do we need to upgrade it? So we have to do a lot of first principles engineering ourselves. We also can't replace everything on theory alone. If you a couple of times when we've got in you know, highly paid consultants or etc., especially from big overseas networks, they come back and they tell us that practically everything has failed. You need to replace everything, but it doesn't make sense. We still manage to keep trains running and keep freight moving. So we have to actually use a little bit of an empirical approach and try and interestingly, as the Compass guys were talking about, we have to find where the actual interesting points are. The theory tells us everything is interesting. We actually need to have better ways of determining what's actually a problem. We're also pretty resourceful, so it's a fantastic place to learn how to not be an overly conservative engineer. We have to take controlled risks, or our whole network doesn't work. It's too marginal. So what are some of the interesting threats and opportunities? And there are dozens and dozens of these, but we've actually, before I move on to those, I might actually ask, is there any questions about the content I just went through, if anybody wants to ask anything? That's one of the threats and opportunities I'm going to talk about. Yep. Yep. That is a very good question. It is actually one of the biggest and most currently relevant threats and opportunities. Yeah. So we have a really big network. It's across nearly all of New South Wales, and New South Wales is a fairly large state geographically. It's easy to forget that. I grew up on the coast in Wollongong. You know, I knew Wollongong, Sydney, Newcastle. I was barely aware there was anything west of the Blue Mountains. It's a big state. To go from, I'm based in Dubbo. Back when I used to be a maintenance person, some of the areas I was responsible for were more than 8 hours drive away from my office. And that was in good weather. If there was bad weather, some roads would be closed down and it could take you more than a day to get to places. So it's a big network. It's the tyranny of distance is very pertinent. So we have a lot of, and it's across a very diverse range of environments. You have the north of the state where there is really reactive clay soils, fantastic for agriculture, not so great for engineering purposes, through to the south of the state where you have the good sandstone basin. You have alpine temperatures, you have desert temperatures, you have everything in between. You have coastal high rainfall areas and arid areas. We get a lot of everything. So you do get a lot of diverse threats across our network. So here are a couple of the ones we thought might be interesting to talk to you guys about. So one of the main threats that we have is just the age of our infrastructure. We still use a lot of wrought iron. We still use a lot of original smaller sizes of rail. those things are not going to go away, but most other railways have taken an extremely conservative approach to managing those. And talking to some of the older people in the industry who were my mentors early in my career, they often say that a lot in the metropolitan areas, the engineers kind of made things sound worse than they were to get the financial people to fund the projects. So a lot of the conventional wisdom about what is required, if you have heavy axle load trains, you're going to need this certain level of rail size and this configuration of concrete sleepers, etc. They are just, in reality, they are very, very conservative. So we are often forced with the question of how far can we push what we have rather than looking at upgrading what we have. So, based on the individual combination of factors, rail, ties that keep the rails together and transfer the load to the ballast itself, its depth, the underlying soil, the formation, how far can we push that? How big trains can we run on it? How heavy can they be? How fast can they go, etc. These are questions that we are not yet very good at answering ourselves, but are interesting areas of research. One of the big challenges we have is that our network has basically no hydrological plan. Our network is built almost entirely through floodplains. The network was built in the areas where the farmers were, and the farmers were there because water was plentiful and the soil was good for growing things. So, and I already mentioned they used the American techniques where they didn't properly build a formation. So we have these massive embankments going through floodplains that act as natural levee banks, and the actual movement of water through them is as simple as when you get a flood event and half the track washes away, you put some pipes in there when you rebuild it. And so our hydrology has been built up very informally without much science, and it's quite frankly not holding up to the climate change we're seeing. Over the last decade, the storm events have been getting more frequent, larger, more intense, and that is actually a major existential threat to us. If you guys probably don't know here on the East Coast, but in 2022, when there was a really big series of storms and washaways, you probably saw some of the impact on Sydney, but there was a period of time where the track between Sydney and Perth was washed away for 3 or 4 weeks. It took a long time to resolve. During that time, Perth actually had grocery shortages worse than during COVID. So they pretty much had empty shelves. People couldn't get basic supplies because Perth is almost all entirely supplied by rail from the East Coast. So, and what came back from industry is there was a series of events where we had multiple washaways and the industry got disrupted multiple times. They were forced to put things on trucks to keep Perth from starving to death. And the industry pretty much said, if rail can't improve its reliability, we're just going to stay with roads. So rail is significantly cheaper than roads. It is significantly better from an environmental perspective, but we are not as reliable. We have massive problems with reliability, and a lot of it comes down to our hydrology. A very interesting technical topic for the civil engineers perhaps is the lateral stability of steel sleepers. It's a problem we created for ourselves in solving a different problem. So up until the early 90s, our entire network was timber sleepers. So there's approximately 16 to 20 million sleepers across the network. They are made from hardwood timber, mostly ironbark, and the ironbark forests were pretty much exhausted at the beginning of the 90s. There was no more supply. So they had to make a decision at that point. The main alternative is concrete sleepers, but concrete sleepers are very expensive and they actually rely on having a good formation. So being typical, looking for a good cost-effective solution, we came up with steel sleepers. They are a hollow U section They rely on being filled with ballast, and they, at the time, were cheap as chips. They were probably 20% of the cost of concrete sleepers, maybe even 10%. And between the 90s and the 2010s, we replaced almost every timber sleeper on our network with steel. Great, we solved that timber problem. They last a lot longer than timber. They have some advantages. However, they have extremely poor lateral stability. So that's the left and right of the track. This becomes a problem for us because our continuously welded railway is like an enormous thin column, and it's extremely affected by thermal stress changes. So some of our areas of our network have temperatures that range from -5 up to 52 or 53. And the rail is typically in direct sunlight going to be 20 to 25 degrees hotter than that. So you can imagine there's a great deal of thermal stress in that range. And the track relies on being able to resist lateral movement, because when the track is in compression, it wants to buckle, which is almost the worst thing that can happen to track. And then when it's in tension, it wants to pull in and become as small as possible. So we've created this problem with steel sleepers, and we're now, I think you guys have picked up on a theme, we don't want to pay for the cost of putting concrete in, which would be the easy conservative solution. We're trying to find innovative solutions that can help us get even a little bit of an improvement in lateral track stability for low cost. That we're actually, we probably only need to improve the lateral stability on average 10 to 20% to actually make that not a problem. That fourth point I've covered in lots of the other ones. Now, I was going to let you talk about some of these. Oh, sorry, I'm doing all of the talking. But this first opportunity is one of Maysam's passions, so I'm going to let him talk about it. Yep.
You may see in other slides that we talk about the overbridges, underbridges. I'm not sure if anyone familiar with these, that rail terms. Do you know a sleeper? We talk about the sleeper, we talk about the ballast. Are you familiar with that one?
Yep.
That's cool. So regarding the overbridge and underbridge in the rail environment, the road bridges over the rail, we call them overbridge, and the rail bridges over the road, we call them underbridge. And to confuse you, if you are working in the road sector, it's vice versa. So yeah, if you just by any chance go to another organization, work on the road bridges or road departments, they use different terms. So that one, for instance, the one at the top is an underbridge. So because it's a rail bridge over the road or over the land. And another things that I would like to a little bit discuss is before going to that new material is about the material that we have in the network. Luke talked about the raw iron and the and the timber. We have, I think, comparing to the, let's say, the Sydney trains, we have a variety of the material in the structures, in the bridges. We have timber, as we said. We have raw iron, we have steel, we have concrete, we have masonry, or another things is a jack arch, bridges. I'm not sure if you have heard of
composite masonry and steel.
And each material has its own, challenges and the requirements. So the diversity of we have the diverse material, we have the diverse, structures. So it means that, a variety of the challenges. And as we said, we have plus 350 overbridges, and out of these 350, about 60 of them, 70 of them are the timber, we can say that rail overbridges. So, and all of them are operational, so they are open to the traffic and daily use, that by the road users. And to give you a little bit, that comparison with the Sydney trains doesn't have any timber overbridges. So I think around 20, 30 years
Actually,
ago.
they just
That
removed
one.
their last one because we actually had to. That they had one single timber bridge left in the whole network, and their heritage people said we should preserve this if it's the last one. And we actually had to help them by saying, look, there's tons of them on the country network. You don't need to worry about this one. Let's get the Sydney one, make it suitable for modern traffic, and you've got dozens of them out in the country. So, but yeah, they've pretty much eliminated. So they would take a very conservative approach. Let's build everything in concrete and steel. Let's not worry about it. Let's, nuke it from space.
Yeah, they started, I think, that program about 20 or 30 years ago. They started the program of the removal of all the timber bridges because it was a challenge. So they started getting rid of all those timber material. But we have them, not only the non-operational ones, the Gonda guy that we show, but also the operational bridges. In terms of the technical terms regarding this image, so rail is obvious, that everyone knows what is a rail. And we have sleepers, those, that steel components that you see in the image, we call them sleepers. There is a fastening that, it's between the rail and the sleepers, or, that just hold the rail in place. And that rock material is ballast.
Yeah. So this is the sleeper. Its purpose is to stop the rail from moving laterally and to transfer the load to below. The fastenings Maysan mentioned connect the sleeper to the rail, but they also prevent the rail from moving through the fastening. And the ballast is a layer of gravel or aggregate that is supposed to be free draining, not very often on our network, but it spreads the load out until it gets to the formation where it's hopefully good enough to not cause any permanent deformation of the soil below. So it's very rare that you have anything like a footing or a pile or any kind of the typical civil engineering things you would think of, where usually underneath all of that is bare soil at some point, quite often clay. So you're just trying to spread the load as evenly as possible so that you don't overload the clay soil.
And to confuse you a little bit again, so we over the bridges, the rail bridges, we have ballast top tracks and we have transom top tracks. And what transom? TRANSOM, transom. And what is transom? Transom is pretty much a sleeper. But when we go over the bridge, instead of calling them a sleeper, we call them transom.
And then if you go through a turnout, we call them a bearer. So,
yes. So it's the same component, but in 3 different locations, we use, that 3 different terms.
Yeah, those are transoms.
Turnout.
A turnout
Switches.
is, did I have, where it goes from one track to another. I don't actually think I put an example. Oh, there's one in the background there. It's on the top right hand side. There's actually 2 of them in a row. Yes.
the component.
And Americans call them ties. So you've got in rail, the Americans use a totally separate set of terminology for almost everything compared to the Europeans.
Except rail, they call just rail.
We all call it rail, yeah. Yep.
Transom. So, okay. Sorry, we use a different term. We have timber transom pretty much in the whole network. So again, similar to the timber bridges, one of the challenges that we have is the repair and maintenance of those timber transoms, because the age of the timber is not comparable to, to other material like a concrete. So back to these opportunities, one of the, that areas that we are interested and we are doing a bit of the research and the study is finding alternative material for the timber. It could be, the alternative material for the timber transom, or repairing the timber bridges with other material. One of the things is that maybe you say, okay, you have 60 timber bridges, fair enough. Why not, renew them? Why not replace all of them? That's one of the important areas in the asset management. In the asset management, you have a limited bucket of money, right? So you should find the best use of that money to maintain and repair your network, your assets, your structures. So just imagine that we have 60, bridges. We can't, spend all of that money to replace and renew all those bridges. So instead, we go with we can say the cheaper option or cost-effective option, which is the repair. Keep the bridge, but repair them. But repairing the timber bridge is not, that I would say cost-effective or sustainable solution, because in some coastal areas, because of the termite, you have to replace a timber components every 2 years, right? And especially these days, finding a timber materials is challenging. So we are thinking to find an alternative for the timber materials for repairing and maintaining those timber bridges.
So importantly, it needs to be resistant to termite attack. It needs to be resistant to fungal attack. It needs to be resistant to fire, but it needs to have properties similar to timber in terms of weight, in terms of flexibility to slot in as a replacement for the timber elements, because the design of the timber elements relies on a little bit of flex and movement. So you can't just, for example, slot an equivalent reinforced concrete.
Yeah.
Where we keep what, sorry? Yeah, so this is another interesting question, is that typically in engineering, you'll have a concept of a design life. You're building an asset to have a defined life, often 100 years. And then at the end of that, there's an assumption that you'll decommission the asset and replace it with something else. On the CRN, our plan is typically an indefinite design life. So we if we can, we keep the asset going forever by doing replacements of components. So a lot of our infrastructure is already past its design life. So that's actually again, typically 100 years has long been a standard in civil engineering. Many of our bridges are 140, 150 years old, and we instead look at how can we keep that going forever? Like, there's not always a reason. So, yeah, we probably will. Some of the interesting things that we'll talk about a little bit later about the long term is really about what industry and society starts doing. So the roundabout answer to your question might be, I don't know, if we as a society think that in 50 years' time, we're going to completely replace all domestic freight transport with drones, individual drones running around and dropping everything, and there's going to be no long distance bulk stuff, maybe we only keep it running for another 50 years. But the way things seem to be going, rail does need to pick up its market share to achieve most of the targets that the government wants to make. So the message we're getting from industry and government is that we need to be prepared for this to be the new normal, that our assets need to do more than they're doing now. And but once that happens, we may be able to justify investment in some of those other things. So we to some extent, we need to bide our time until other things become cheaper and more viable, or we make a decision to decommission the asset. The non-operational ones, we typically do no maintenance and simply try to decommission portions of the asset that have public interfaces when they get to a critical point, like over a road, for example. But yeah, that has been a topic of a lot of debate with the non-operational ones, whether if you look at some of the legislation around those assets, the government should have been keeping them in an operational condition if they didn't formally decommission them. They didn't, and we now have assets that cannot be safely maintained. The only sensible thing to do is to demolish them and rebuild them if you must maintain them again. So.
And regarding that, one thing to add regarding the non-operational one, that was a good question. Again, back to that asset management mindset, you have a limited, bucket of the money, right? So, and in this network, you have plenty of the operational assets. And non-operational assets doesn't have a return of investment because there's no train, nothing on them. So you as an asset manager prefer to invest in the operational ones because they are serving a purpose and they have a bit of the return of investment. And you ended up, that spending all that bucket of money for those ones. There is no money on them. And most of them was closed, let's say 30 years, 40 years ago, like the Gandaga, that we presented. And because of that, there was no investment in the repair. We just, keep inspecting them and they are getting worse and worse.
And that worked in the short term, but
Yeah.
we're now starting to get to the point where a lot of those assets must have intervention now. So that's a very topical point of discussion. It's almost, if any of you have ever been involved in like tech development, it's almost like the concept of technical debt. It's like asset debt. At some point, someone made a decision to stop servicing and maintaining those lines without deciding what their plan to decommission and dispose of them was. So now they have a massive problem in the present day because they've reached critical levels, and there are public safety risks to a lot of those.
Has anyone traveled to the regional areas? Like which city? Davao.
Yep.
The reason I'm asking is that because in some of the places, most of the places, like Lismore, for instance, like Batter, Davao, you can see, that some of these, timber bridges. And just imagine that these timber bridges over the public road, they can be a public safety risk, hazard. Yeah, exactly. And some of them are heritage. So, working on these heritage assets, it's another challenge. I'm not sure how much of any of you are familiar with working on the heritage listed asset, especially state heritage. You know that if you want to touch them and do something, it's a headache. It's another challenge.
It takes years just to get the case to go in and do minor stuff on them. Yeah.
So you have a question here.
Yep. Yep.
That was a good question.
Yeah. So the network that we operate is mostly owned by an entity called TAHI, Transport Asset Holding Entity. TAHI. They're now TAM, or they will be from December. So, but effectively it's the New South Wales government. So we maintain that these are all New South Wales government assets. We are a private company that has the contract to do the operations and maintenance. So we effectively do all the same stuff that Sydney Trains, that ARTC does. We run the train. Well, we coordinate the trains. We're not the people that actually provision the trains and that sort of stuff, but we control the traffic, the movement of the trains around the network. We maintain the infrastructure, we inspect it, we control access to it by third parties, we make investment decisions, etc. So but we do that on behalf of the New South Wales government. So it's a taxpayer-funded network. It's not a financially profitable network, so we spend more on it than what we get back in, say, billing revenue. But it's a very strongly positive economic return in network. So in terms of the economic activity that's generated by the expenditure, it's quite strongly positive. Yep.
Do you have another question?
Yep. 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 Yes. Yep.
Road over bridges.
Road over bridges over the ARTC network.
Yeah.
Yep. Yes. Yep. So that is specifically one of Maysam and his team's responsibilities. Is every single heavy vehicle movement in the country is planned. So when they want to do a heavy vehicle movement, they have to apply to the regulator, and the regulator contacts all the agencies, roads, infrastructure owners that the journey goes across, which is, for us, is our level crossings and bridges. And then we tell them whether it's safe. So they're about to kick off a massive program of construction of renewable energy zones. Some of you may know about that. It's going to be 30 movements per day for the next 4 years out of the Port of Newcastle of wind turbine blades, transformers, and tower sections.
Yeah.
30 per day, and they are very heavy. They are very long. Every time they go over one of our bridges, we have to model it and tell them whether it's safe, because almost invariably they exceed the design capacity of those bridges. Most of our bridges, we go pretty low on the safety factor sometimes, below. In terms of safety factors, we've been asked to permit loads as low as a total safety factor of 1.09 compared to, that's pretty low for a.
Yeah. Anyone, that forum is familiar with bridge analysis. Have you done any bridge analysis? Cool. That's good. I think it's road bridges. You may see sometimes, not all the times, you may see some signage. That 50 ton, not 50 ton, 20 ton, 30 ton, whatever, or sometimes give you the loading for the single axle, tri-axle, and tandem axle. So that's some bridges, if they cannot satisfy the criteria of the general access vehicle, which I explain later, then we have to put the signage next to the bridge and say that above this signage, above this load, you can't go over the bridge, right? So general access vehicle is a semi-trailer, 42.5 ton. If the bridge can satisfy that criteria, then we don't put the signage on the bridge, which means that general access vehicle can, go over that bridge. But just imagine that there is a case, there is a freight operator. I'm a freight company. I have a big truck. I want, to go from Melbourne to Brisbane. In that case, I have to pass, that over some bridges. And that vehicle is above the posted signage. So what happened is that they, that send applications to the asset maintainer, which is Transport for New South Wales, and which is us for the CRN, because we are, as I said, we are taking care of some bridges, and say that, hey, I have this vehicle, and this is the axial spacing, axial loading. Can I go that one? We assess, we do a bit of the number crunching, and then based on some safety factors, we come up with a condition and say that, hey, that the speed shouldn't go beyond that one. You should, that go with this lane. There shouldn't be any other vehicles, and that sort of stuff. And that's why I was interested, that specifically about the heavy vehicle stuff, because, that I can be curious. Okay, I have to
do people actually comply with the restrictions that we put on them?
Exactly.
It's a question that we get.
It's a kind of the, that cross check. Yeah, exactly. We impose those ones, and then, they can use that one. And after the COVID time, we received a massive, load of these applications.
Been more than a 1,000% increase in heavy vehicle movements in the last 3 years.
Yeah, exactly. So again, we can say that RIM, Rail Infrastructure Manager, ARTC also is a RIM, CRN is a RIM. But even if we are a RIM, as you can see, we have to also take care of the road traffic as well. We have some interfaces with the road traffic. So it's not just our challenge, it's not just that rail infrastructure, also is the road traffic and other stuff. Back to this topic. So I talk about the alternative material. One is the that bridges. Another one is the transoms. We are thinking that to replace the timber transoms with, again, some other materials, and even some small improvements in the structures, that can go a long way. And back to your question about the life. So the more life we can get, the better. We can, put it in the simple word. If just imagine that there are two, options. One of them can extend the life of the asset for 50 years without imposing significant cost. Again, it's a cost-effective solution. That's a gain. as Luke mentioned, we have, that some assets plus 100 years old, and some of them are heritage. So we are not in a position to replace them, to be honest. So it's better that to maintain them for, again, another, that 100 years.
It's one of the interesting things about, I'm going to speak to asset management and maintenance as an engineering discipline. So I think you guys get a much better experience these days. Back when I went to university to do civil engineering, 90% of it was about design, and there was sometimes people also build the things that you design. So here's a course or two on what an excavator is, and some very basic construction stuff. And then when you actually get out into the field, asset management is usually not anybody's first discipline, but I've always found it fascinating because we're the ones that decide there's a reason to design and build something. So in the context of what Maysam and I do, we are always solving problems. So we have the network the way it is. We have people coming to us with problems. We want to access this. We have a problem with this, and we're applying engineering principles to come up with solutions that are often not, let's knock it down and build a design thing. It's what can we do with what we have, or what's permissible, or what's the risks of doing it if we do permit it, etc. It's a very interesting topic of engineering, and you don't learn enough about it in an undergraduate context, or at least you didn't in my day. So hopefully you learn a bit more about it these days.
You want to talk about the hydrology?
Yeah, this second topic, the hydrology, is one of my passions. So there's so much we could be doing in this space, and there's a really good example of something we're actually trying to push. So I talked about the problem, I suppose, at a micro level with individual site drainage. We now have satellite-based weather monitoring. So we, across our entire network, we have tapped into a service that provides us with real-time information about rainfall, wind, temperature, based on satellite information at approximately a 1 to 2 square kilometer grid, depending on the satellite coverage. So we can actually, we use it at the moment to trigger special conditions when there's rainfall events. So say it's 2 a.m. on a Saturday, and all of a sudden there's 50 mils of rain falls within 30 minutes, 3 hours from your closest maintainer, and you've got a train coming. You need to make a decision about, do we stop that train? Is there potentially, if a freight train is coming and the track is washed away, there's very little chance they'll be able to stop in time, especially when the visibility is not good. So we now have the capability to at least detect when there's rainfall, and we've started to implement some basic risk controls around that. But I think we can take it one step further. We should be able to build a hydrological model of at least our network, if not New South Wales. Most of them already exist, and marry these two things up. So if we knew what is the catchment area of every single section of rail, what's the upstream, we can feed the actual rainfall data into it and predict, based on the rainfall we've just seen in 6 hours, this culvert is going to become overloaded and we should do something. Or in our context, what we also want to know is, let's not do anything. Actually, the rainfall, maybe it triggered a threshold, but it's fine. There's sufficient capacity in that hydrological basin, or the culverts are good to handle it. Let's not interrupt traffic and keep it moving. So we actually think there's a great untapped potential. There's networks around Australia and around the world that have done either side of those things. They've got good maps of the hydrology models of their network and their culverts, or they're doing what we're doing with the satellite-based rainfall. But we have not found anyone that's doing both of those things together yet. I think this is one of the most exciting areas of interface between civil engineering and technology for me. I'm very passionate about that one. So we would like to get to a point where we can, in real time, know where the risks are. And this is a serious risk that could lead to fatalities if not addressed correctly. The fourth opportunity is very much an area of transport logistics. So one of the great things about engineering practice once you get past university is careers are very long time, and engineers practically all become generalists as you go through your career. You learn about the adjacent disciplines, you learn about the topics that come with it. Not technically a civil engineering topic, but you learn about some of the economics of the railway. So if we go back to our network map, I'm going to bring up big one. Actually, that's probably too small. Those commodities represent around about 10 to 20% of what is moved in what is actually produced in New South Wales. Rail's market share is very bad in Australia. It's actually extremely bad by a world standard, and it's particularly bad in New South Wales. In a lot of areas, there is potential for more traffic to come on rail. Every freight train takes approximately 130 heavy vehicle movements off the road, or more depending on the longer trains as well. We are cheaper, we're much lower emissions, we're a safer mode, but I've already mentioned some of the challenges we have about reliability. We're so heavily regulated compared to the roads. I mean, if you are a freight operator and you know I'm producing widgets at a factory here and I need to get them to the port, you go and you talk to the rail, there's so many hoops you have to jump through, or you can just go and put a truck driver on. They go and do a 2-day course, they hop in front of a truck, and you can have them online within hours. So we struggle to meet our customers' expectations in those areas, and there's a huge need for us to work out where the most impact is. So that we have maybe there's some corridors where there is a much greater economic impact or a much greater impact on the task of achieving zero emissions than other corridors. And we're not in a position where we know those things necessarily, and our potential customers may not know those things either. So there's a great deal of inertia in the freight market. If once somebody is comfortable with a particular mode of transport, they're not constantly reevaluating their options. So even if, for example, in the last 20 years, rail has become more competitive or any other thing, most operators are comfortable with what they know. So they're not looking to change. In a transport planning context, one of the key constraints in Australia is actually the port capacity, the rail capacity at ports. So there's only so many freight ports in New South Wales. Most of them have 600-metre long berths for trains, but train companies want to run long trains because that's what's profitable for them. So they have these big 1,800-metre long trains that come in from the regions that spend a lot of time breaking up and shunting around and wasting very expensive port access time, and it constrains the port throughput. So increasingly, they are starting to build multimodal terminals where the regional trains will come in. I think your students did a site visit to one, did they? Or was that a... Yep. Yeah. Yep. But increasingly, what they will do is they'll have a outer metropolitan freight handling facility that can take the long trains, unpack them, and then put them back onto short shuttle trains that go directly into port and don't waste any of the expensive access time at port, but still get the advantage of the efficiencies of moving large amounts of freight over big distances. So we as an industry are very fragmented. There's a lot of different operators. There's just us, Sydney Trains, and ARTC just in the freight space on the rail side, plus all of the different train companies, plus the freight companies that act as intermediaries between the companies that actually produce the goods and it's such a fragmented market that it's hard to get everybody to move in the same task. So there is a need for research that tells us how do we quickly get wins in this, and what are the areas that we need to invest in, or that the government needs to invest in. So how do we get more of that grain off of country roads where there are we heard there's already single vehicle accidents and all that sort of stuff. Anybody who's ever driven on a country road and you get stuck behind a road train, the road trains are creeping ever closer to Sydney every single year. It sucks. You can't pass them. You can't do anything. They cause potholes all over the place. And those costs are largely invisible because freight operators don't pay them. Whereas in rail, they're directly incurred costs. So yeah, that's another very interesting area. But yeah, sure. Yep. 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 There's nowhere to park them, so they pretty much have to park outside of Sydney, and then access into Sydney is very, very precious because the Sydney network is pushed pretty much already to its limit in terms of what it can do. And you may remember the New South Wales government had a more trains, more services push for the last 10 years. Those passenger services, which is what the government definitely considers the passengers its priority rather than the freight, and the passengers are consuming more and more of the available windows. So the freight gets shrunk and shrunk just to outside the passenger times. So you're right, there's nowhere for the trains to actually wait in Sydney for a port access. So they often wait outside of Sydney. Lithgow is a big holding yard. So they'll come down to Lithgow and they'll wait in Lithgow, and then it's, okay, your port window is in 4 hours, so head down now. So part of the government strategy with building the metros is to relieve the need for a lot of the heavy rail above ground stuff. And yeah, correct. So now that you have the next stage of the metro opening, and once you have the West Metro and the what's the other one? Anyway, the Southwest Metro. Once those pieces, there's probably not as much need for the traditional above ground passenger services, and you can really pull back on those and do what above ground rail is really good at and do long distance stuff. So, maybe if you're going to Penrith, you hop on a train and it stops at Granville and Penrith, and there's no ones that are all stops, and everybody else catches metros and that kind of stuff. So, and then you use that extra capacity for extra freight windows. But that's sort of thinking is still 5 to 10 years off. Another big problem in that regard has been everybody in the country is trying to do the same thing at the same time. So the East Coast infrastructure boom was twice the size of the mining boom in terms of dollars of investment. And that has massively constrained access to resources. And that means things are more expensive to do. It's great for people in the industry, by the way. You guys are probably coming through uni just a little bit too late to take advantage of it, I'm afraid to say. But it's great to be an employee in an environment where there's lots of work going on, but it's not good for the taxpayer because it means that things cost more. You're competing the same 5 or 6 companies that do all of this kind of construction are delivering $100 and $150 billion worth of work at once. There's only so many materials, skilled personnel, plant and equipment, etc. So it should have probably started 10 or 15 years earlier and been spread out over a bit more time. At the moment, if the government was to announce a new mega project, the industry would groan rather than be excited about it, because it's just yet another challenge of we already can't employ enough people. We already can't get access to enough market capital. We can't get access to equipment, etc. We don't want more work. We want the work to steady out a little bit. Yep. That's pretty much all we had. But what I'm hoping is that that we've planted some seeds in your heads about some interesting problems. These are all the things we mentioned are unsolved problems. So it's fantastic to be able to play in a space where you know that nobody has yet come up with the answer, and you can actually come up with it. And on our own, we're probably not going to come up with these answers. So we definitely need help from academia, from students, from people with the right ideas to come through. And it can be as simple as your idea ends up influencing policy and strategic direction for the entire country, really. Some of these problems will actually determine whether some of these modes have a future or not. You solve one of these problems, you could actually guarantee rail's viability, or it's actually fantastic to see the sort of individual impact. This is beyond, it's beyond building a single asset or designing a single. I mean, you're all students. You've probably designed a dozen car parks and buildings and that sort of stuff in your practicals and tutorials and that sort of stuff. It's bigger than anything like that. These problems are society level stuff that you can influence with some application of some engineering fundamentals. So, yeah. Got a question. Yeah. Yeah. Open Q&A. Yep. I'll put this down. Yep. That is an important topic. Perhaps not as important for us. For whatever reason, they don't seem to care about that as much for regional cities as they do for, say, Sydney. But it makes sense. You have a railway running through Sydney. A noisy service may impact on 10,000 nearby residents even in the biggest regional city. You might only impact on, say, dozens or hundreds. But that is very important. A lot of noise in the railway comes from the friction of the steel wheels running on the steel rail and the control of that interface. There's a very, very narrow band of friction that you want to achieve to have the right traction without causing problems. So that's an entire discipline. I could speak for another couple of hours on that particular topic, but yeah, that's both controlling. Yep. Yeah, so we are in control of the rail cross section, and industry has some standard profiles it uses for its wheels. It's actually one of the areas Australia is uniquely bad at. We actually were the world leader in this in the early 80s, and Dr. Stephen Marich, who was in Victoria, was actually one of the ones that introduced the concept of coordinating the shape of the rail and the shape of the wheel so that the wear patterns between them meant that you got the maximum viable life. We were really good at that. And then in the early 90s, we took away the vertical integration of railways. So typically now the freight operators who manage the wheels are not the same people who manage the rail profiles, and both sides have become very selfish. So our current rail profiles maximize the useful life of the rail, and the current wheel profiles maximize the useful life of the wheel. And those two things are not aligned with each other. And that is an area where there could be improvement. And we ought to be looking at redesigning the profiles and ones that work the right trade-off. Again, like anything, the more the rail wears, the less the wheel wears, and vice versa. And you need to find the right balance between those things. Yep.
Obviously, you do the analysis.
Yep.
As like what that involves.
Yep.
And because there are like so many variables, like how do you kind of like address the variables?
Yeah.
I'm happy to take this one.
Sure.
Yeah, there are different variables, so it's a little bit, difficult to explain all of them. But briefly, touch on that one. One of them, obviously, is a material. So it's a kind of the benefit cost analysis, and one of them is that how often you repair that structure. Is it every 2 years, every 1 year, every 5 years?
Or is it repairable?
Is it repairable?
Yeah. So
that's another question.
Yeah. Actually, to take it, I'm going to jump in there, Mason, because I think there's a better way of framing this answer from the start. Is that the method we use is called total cost of ownership. So what we look at is what is the lowest cost over the life of that asset. So you may say that something is half as expensive to build, but then every 10 years you spend a massive amount of money doing a major refurbishment, and so the total cost of ownership is higher. So we typically use a horizon of about 50 years of cost on that. There's no science necessarily behind that. It's just a standard practice in New South Wales. So you could equally look at it as 100 years or less. There's no right answer. But I suppose the longer you go into the future, the more uncertain you are about cost utilization, technological changes, etc. But anyway, what we try and do is we try and look at what's the cost over 50 years. So if we take building a new bridge, we have some ones we're looking at the moment in the Hunter Valley. So they are key heavy vehicle routes in Newcastle. They go over ARTC's tracks into the port. We only get access to those tracks for 1 or 2 days a year. That's the only time the trains stop to go in and do maintenance. And the road vehicles that are going over it are heavy vehicles all the time. So if we were going to replace those bridges, we would want to replace it with something that is completely no maintenance. You would do something. You'd probably end up with something like a big through truss bridge or something like that. That may cost $50 to $80 million to build, and then maybe you'll get 100 years of life out of that or more. We are looking at what can we do to make the ones we have go another 50 years and avoid spending 50 or 80 million. So we're currently looking at some we look at what could cause this bridge to fail. So on those particular bridges, what's currently causing them to fail is water ingress through the deck is starting to attack the steel members and cause corrosion of some of the key members. So we're looking at, can we spend $2 to $3 million upgrading the deck to keep the water away, do some minor replacements, and then maybe do a better program of road sealing. Let's say total cost over 50 years of $10 million. Then we spent $10 million instead of $80 million to replace it. So that's the way that we would compare those things. And it doesn't always stack up in favor of doing the maintenance stuff. Sometimes the best answer is just knock this thing down and replace it with a new one. But
a couple of factors that I'd like to add is some intangible factors.
Yeah.
Because, again, our, asset portfolio is a little bit different from the Sydney trains. We have plenty of the bridges in regional areas with some low population density. And we have some bridges next to, few properties. And, adding to the Luke's point, we should see a usage of the bridge. We should see that, okay, if this bridge is next to a couple of properties, would you replace that one or another bridge that is in the, that middle of the town? Because that one has more usage, more traffic, and it serves to more, that members. That's a kind of the assessment that you should do as an engineer, that instead of investing in that for the replacement, better to keep that one, but let's, replace the one that has more usage, has more services and can serve better if we upgrade that one. And another, back to the point I mentioned about the load limits that we post on a bridge. Let's say that I have a bridge that I have to impose a 5-ton load limit on that one. I'm creating a problem for the community because the community cannot use heavy trucks, cannot use that bridge. And there are some farms, just imagine that there are some farms next to that bridge. So they have some trucks heavier than 5 ton. So again, I'm creating a problem with imposing that one. So I should think, okay, what are the options? Can I make a kind of what we call it major refurbishment to get rid of that one? If I can't, then what if I replace the bridge? Because if I put the brand new bridge, I don't have to impose a load limit, and then most of these heavy vehicles can use that one. These are the kind of that competing parameters that we should think of.
Yeah, because the other thing to keep in mind is that our annual budget for doing works across all asset classes typically is about 50 to 100 million across the state. So doing something like an $80 million bridge replacement would suck up our entire works budget for the year. So we try and avoid that kind of stuff at all costs. That may not necessarily always be the best long-term investment. So it may be the case that over the longer term, we should look at doing a bunch of targeted replacements with a massively increased budget, and then the back end of that period is cheaper. But that's not been the, I suppose, political situation. You're always, as an engineer, it sometimes sucks to say you're kind of at the mercy of what the politicians and the money people want to do, and you may have a really good solution, but you can't convince everybody to do it. So another bit of advice I'd give you guys is work on your skills in terms of selling the benefit. Maysam just put it perfectly. It's not always just about what the numbers tell you in engineering. It's about how the story that goes with it and what you can tell people that control the money that aren't engineers and don't care about how amazing your solution is. What they want to know is usually, how much is it going to cost me? What are the customer benefits?
There was a question on back of.
Yep. Yep.
Mm-hmm.
Yep.
Sorry for the image on the transport.
I didn't quite catch the last question. Yep. Yep. Oh, climate change. Yeah. Yep. Yeah. So those are all great questions. So the satellite data that we're getting is from a third-party company called the Early Warning Network. They partner with a international company that has a growing, I don't think you call it a fleet, but satellites in the sky, and that they have it's actually that a lot of the data that they gather goes into meteorological models around the world, and they've recently started selling that as a service. So we had actually come to them because we traditionally rely on rain gauges. So for example, traditionally, to know where the rainfall had happened, we would be looking at what the Bureau of Meteorology's rain gauges said. Like, I'll take Dubbo as an example. The rain gauges at the airport, at Dubbo Airport, and that may be the only rain gauge we have for 200 kilometres. So you get a massive rain burst at Dubbo. Where should you be responding? We may have several hundred kilometres of track in between there. And you may have a small rain event that isn't even captured by that. So what the problem we took to them was, how do we actually get better than what the rain gauges have? And what they have developed is a method of measuring the rainfall, again, at about a 1 square kilometre resolution at the moment. It'll get better as they get more satellites. But it's not my area either. I don't 100% understand how they do it, but they've done a lot of ground truthing and testing to see that it's accurate. And we now pretty much get a GPS overlay that says where the rainfall happens. In fact, it's their platform has an API that we can draw from. So we're currently only using that to drive our alert system. The second part of your question about the hydrology, we're at such an early stage of that we don't know what the right answer is. One part of it is even understanding which model we should apply. Should we apply any of the numerous traditional models? I discovered once I got out into industry, I mentioned I studied at the University of Wollongong. My hydrology courses were all using a model called watershed-bound network model for hydrology, which I subsequently learned is mostly driven by the University of Wollongong and not the industry standard practice. But there'll be different advantages and disadvantages to different models, but given the context, what we would like to do is be able to drive rainfall at a particular area. Where does that water go and what's the time that it gets there? So for me, that sounds like a watershed model, but we don't know what we want to do with that yet. So if that could be an area of research, is even just looking at like an options study of what could be done, what are the costs of collecting the data, what are the costs of building the model versus what are the advantages and disadvantages of each model, what are the biases of each model. These are things that we don't know what we want to do with yet. As to climate change, we are already seeing the storm intensity is the main thing for us. The variability of rainfall, the last 10 years have had almost no years on our network where things have been typical. We've either had it being incredibly dry and arid, which comes with its own challenges on a clay network. Plus our customers don't grow grain when the water doesn't fall. But yeah, we're already seeing every single time we get a high intensity storm event, we're getting impacts on the network, and they're increasing in intensity, they're increasing in frequency. So we, ARTC, our adjacent network, actually just announced a $1 billion investment in its own network hydrology. As I think I already mentioned, that would be an unthinkable amount of money for us to invest in our network. So we're trying to take a slightly different approach. ARTC is taking let's just engineer out the risk. Let's build a bunch of infrastructure that can handle anything and not worry about what's coming. We're trying to think, can we invest in making a smart decision about where the actual important parts of our network are to fix? And that model may tell us, you really need to fix the culverts or the bridge capacity at this location to have the maximum impact. And then we can do a small number of interventions to get the most benefit out of it.
I looked also to add another point regarding this hydrology, because it's a relevant area to my discipline. We didn't mention that one. We have about 4,600 culverts in the network. So it's a massive portfolio of the culvert asset that we have. And just imagine, we need to repair or renew, again, these assets, back to that previous question regarding the repair versus renewal. So it's important to us that pick the right location for the repair and pick the right location for the renewal. Some of the culverts might be in a good condition from the structural engineering perspective, but from the hydrology, their capacity is not enough. So these kind of studies and models can, can help us to pick the right locations and make a right decision. I said, okay, we need to renew, the culverts of this, area. And it's important for us, and it's a little bit challenge for us, to study all these, that 4,000 culverts. That kind of, studies help us to go to the shortcut and, that make a best decision in a
because of the floodplains, the local hydrology doesn't always give you the picture. Like out on the Cobar line, which is proper outback desert conditions, you'll see these enormous culverts that are like 100 cells, and you'll be like, where does the water come from? There's no river. There couldn't be that much rain out here in the desert. But believe me, because the land is so flat, once the rain starts falling, it just comes in huge waves. And so if you just looked at the local hydrological capacity, we've had this when we've replaced a bridge or a culvert or something like that, and the designers come back to us and they say, the numbers say you only need a 2-cell culvert and you've got a 100-cell culvert. So, why aren't you building the 2-cell culvert? If you look at the broader hydrology, you'll find so that's a little bit of, I suppose, narrow thinking on asset owners. It's not just unique to us. Everybody does that. So some of these things are systems. They're big systems. We need to have better ways of managing how water, and you know, it's water, it goes somewhere. So, you know, we've had cases as well where we've found a problem with culvert capacity. We've upgraded the culvert, and then the road next to it becomes completely flooded and unusable because they've got a culvert. And then the property, the next one downstream, gets flooded because now suddenly the water's getting through and getting onto their property. And you just have this cascading problem of the water having to go somewhere. So it needs to be more coordination between parties. Mm. Yep. Yep.
For researchers and also, you know, for you guys, if you're doing your honors or master's project, the research project that we can pick, it could be a really good scope of work for you guys that you can, you know, make sure that at least it will be picked up by industry, the research that you're going to do. The second one actually was the innovative construction material to basically either strengthen the timbers or steel sleepers or replace those with a, you know, very low cost and also effective methods. The third one, which is more on transport and logistics side of it, that as Luke mentioned, the first line that you provide, so the access to farms and how actually we can kind of, you know, with having more intermodal terminals, depots for freight rail, and also with educating the industry how we can kind of increase the freight rail model share and also removing some of those barriers, like this is that 600 meters of limitation of freight trains, that of course there are sidings in this area. There could be some work for scheduling of freight rail services to avoid the conflict with the passenger trains in the city network, because as much as the first mile is important, but also the last mile also, you know, the connectivity to the port interface is important as well. In terms of the total cost of ownership, the CapEx, OpEx, capital expenditure, operational expenditure, and also the net present value. So you all learn this net present value, cost benefit analysis, total cost of ownership, that kind of things. But then, you know, how you can actually measure the benefits. So the benefit that Mason, for instance, mentioned, is not only for UGL, the operation of rail, it could be the benefits for access to farms, to all the other industries, road sector as well. And so when you're actually looking at the cost benefit analysis, the net present value of the investments that you're going to do over 10 years or so, then what would be the benefits for society, the benefits for the public sector, the benefit for government, and also the cost as well. What else? I had another point in my mind. Hydrology, yes. Market share, yes. I mentioned about the increased present market share. So I think the way forward would be now you learn about these industry gaps, industry research gaps, right? So what actually industry needs that? So now you can pick some very relevant projects in your master's or honors, hopefully that will be useful for industry, and then even like it could pave your career pathway afterwards, because you may actually have a buyer for your research later on. So
I will say as well, both Maysam and my careers in rail started with a research project at our undergraduate into rail topics. So, yep.